In this video, I'm going to show you guys my brand new 3D scanner and 3D printer and how I use them both to make a custom car part. What's up everyone, it's C-Joy back with my supercharged E46 M3, and today I'm going to do something fun. This is really exciting for me because I feel like I have a new tool under my belt, but I did just pick up a 3D scanner and 3D printer, and I'll show you guys what I'm planning to make with them. Here's my car. Don't mind the little dots. I'll explain what those are in a second. But for those that remember, I did relocate a custom oil cooler here behind the fog light. The reason I did that is because the intercooler was blocking all that air and was causing my car to overheat, so this was my solution. What I didn't show you guys on the last track day was I also made a custom duct for this oil cooler. All of this is sheet metal, kind of hard to see. I'll pull the bumper off in a second. But the purpose of the ducting is to prevent the air from going to places I don't want to go and to really force the air to go through the oil cooler to maximize its efficiency and cooling capacity. With the bumper removed, you could better see the ducting that I made out of sheet metal. And unlike the ducting I did for the front mount intercooler and radiator, it's a little bit more ugly. The reason was it was very difficult to make this duct, mainly because the inlet of the fog light cover on the bumper that I removed is kind of not flat. It was like an oval and a weird angle. So unlike the intercooler and radiator, where all the faces were flat for me to make the ducting around, that wasn't the case for the bumper. So I was thinking to myself, what would be a better way to make this ducting for the oil cooler? And that's where I came up with getting a 3D scanner and printer and see if I could do something a little bit nicer looking and probably more functional than this sheet metal. The way I'm going to go about this is I'm going to use a 3D scanner to scan the car with and without the bumper. And doing this will give me a 3D model of the bumper and the oil cooler. Why that's super useful is then I could take those models into Fusion 360 or any CAD software that you're using, then be able to design a duct for it. And this is different from me mocking up cardboard and cutting pieces of sheet metal, because this time we're working with CAD. And in theory, it should be pretty accurate. So whatever I draw up in CAD should fit easily on the car. So if that's true, and I 3D print those design pieces, then in theory, it should also fit with no problem. So that's the plan. This is my new 3D scanner. It's an Einstar Vega. And it's an all-in-one system, which is pretty cool because traditionally you have a 3D scanner that's hooked up to your laptop that you would need to drag around every time you scan something. But everything is built in. You could just scan on the go and not worry about cables or whatnot. So that's why I went with this one. And this is just a GoPro hooked up to it because I'm going to show you guys how I scan this thing and what the screen is kind of showing. Going back to the car and why all of these dots are on it is because it actually helps with the 3D scan. So as you're scanning an object, sometimes a 3D scanner can be challenged when moving from one area to another. The way it knows that you're actually moving from point A to point B is it needs to detect a feature or some texture to kind of know where it is in space. But given that my car is dark and reflective, two things that are very difficult for a 3D scanner, placing these temporarily on the car will help with the tracking. Okay guys, I'm gonna get ready to scan the car. I've already done this, but I'm doing it again just to show you guys what the whole process entails. So let me show you. Basically, you could see the image of the car starting to show up on the 3D scanner. To the right, you could see if you're too far or close. So you always need to be in that range. And then all the red dots is basically all the tracking stickers that I showed you guys earlier. And that just helps with the scanning. So I'm gonna hit record here. And now all you gotta do is wave the scanner around. And as the model turns from red to green, green is just an indication to let you know that you got good data on that object. Once you're done, you can review it. Pretty cool. Then if you like it, you hit save. And here is the final model. Then I would hit save, but I'm not going to because I've already done this. But now let me show you what you got to do on the CAD software side. Let's see how those 3D scans came out. I'm using StarVision, which is the software that comes with the Einstar Vega. And in front of me, I have the bumper. So this is the scan with the bumper, and you can actually see some of the oil cooler in there. But if I look at it from the other side, given that the bumper is in the way, didn't quite scan all of the features of the oil cooler that I wanted. So what I did next was scan the car without the bumper, and now I could get all the features of the oil cooler. It's not perfect. You could see in this mode of scanning, which is the fast scanning mode, it doesn't have like the most precise scan. You can see a lot of imperfections, but for my purposes of just getting the general idea of where the position of this oil cooler is, it works. Additionally, I did take a high scan image of just the fog light inlet, because this is where I'm going to be basing the geometry of the inlet, and I kind of wanted a higher resolution of this part of the car. So this is a different mode of scanning compared to the fast scan mode versus the high def scan mode. It's so high in detail you could actually see the little stickers for the tracker that I place, and those are very slim or thin stickers. And in the high definition mode, it takes longer, but it really captures all that detail. So the reason I did the scan with and without the bumper is because now I could align the two. So there is a align tool here, and I want to align the front of the car with the front of the car minus the bumper. And there's different ways to align it, but since I'm using the markers, I'm going to use the markers. And what's cool about it is I could choose markers that are common between the two scan models, and I want to align it to that oil cooler. So say I choose these 3 points on the oil cooler, I'll do the same on this scan, the same 3 points. Given that I know these are the exact same 3 stickers from the two models, it should combine them together pretty perfectly. And I did this because now I could take this over to the CAD software, and I have like the full model of the outside plus the inside together. So let's get this exported out to CAD and start modeling our oil cooler duct. Before I open up the scan models in Fusion 360, which is the CAD software that I'm using, I kind of just want to show one main tool that I use to make the oil cooler duct. I'm not going to show every step that I took to make the oil cooler duct, but I just wanted to show like the main tool that I use. And that main tool is this Loft tool. Basically, this allows you to make a sketch of two shapes, and then it will automatically generate a solid to kind of transition from one shape to the next, which is basically what the oil cooler duct is. I have the geometry of the opening of the duct as well as the geometry on the oil cooler side, which is a much simpler geometry, which is just a square or rectangle. But this Loft tool is what's going to allow me to kind of quickly model a solid between the opening and the oil cooler duct. So I'm gonna first make a circle. Again, I'm not gonna make the exact like shape, but I just wanted to give an idea of what it took. So I'll pretend this is the opening of the fog light duct. I'm just saying it's a circle for now. So I made that sketch. I'm gonna make a new plane. Say the oil coolers, say 125 millimeters away from the duct opening. So I'm gonna draw that square or rectangle. So basically how the Loft tool works is you click Loft and you basically choose your first profile and then your other one. And then you hit OK. And see how Fusion 360 does a pretty good job kind of transitioning from one shape to another. And this is what I use to pretty much make the design of the oil cooler duct. Here's the scan model now imported to Fusion 360. And why I did all those different scans and aligned them together is because now I can see not just the opening of the fog light, but I could also look at the oil cooler. So again, having multiple scans and combining them pretty much gives me a good view of what it takes to go from the opening of the fog light duct to that oil cooler. Additionally, you could see that the fog light opening has better detail or more precise scanning because I did do that high definition scan there because this was a critical part for me that I wanted good precise data to base the oil cooler duct design on. So again, I'm not going to go through all of the steps to get to the final product, but again, just emphasizing how cool the Loft tool is. Basically, looking from like this angle, I did a sketch of the duct here. Again, same concept. Instead of a circle, I made a fancy sketch around the opening of the fog light part of the bumper. And then you could also see the outline of where I made the Loft tool go to. So this is the oil cooler opening. So again, it's not even a perfect square or rectangle. I made this little radius here because there was an interference with the car part here, and another reason why it was so difficult to make this out of sheet metal because it's just not a perfect square. Let me see if I could show you what I mean about why I needed to make this radius. Okay, I found the scan data that had the part of the body that was kind of in the way when I was making the duct out of sheet metal. So looking at it front facing, this is the part I needed to avoid, and why I made this radius around this to clear it. Again, easy to do on CAD, a lot more difficult to do on sheet metal and with cardboard and whatnot. Now that I got the sketch for the oil cooler as well as the fog light opening in place, all I gotta do is use the Loft Tool to create a body that transitions from this geometry, from the fog light opening to the oil cooler. So I've already done this, so I'm just gonna unhide what I've completed. But there's the oil cooler duct. In theory, if it fits in CAD, it should also fit in real life when I get it printed. Pretty cool if you ask me. This is the cross-section view of just the oil cooler side. And this is the side of the bumper. Easy peasy. Here's my messy office, my racing sim. But I got me the Bambu Lab X1 Carbon. Super good printer. Well, I don't have a lot to compare it to, but it's super fast and very happy with the print quality. Been busy printing all kinds of weird stuff. Lots of waste. I still got to install the AMS system for it as well. But yeah, gonna be printing a whole lot of parts. Here's the first print of the scoop. Really happy with the way it came out. Just PLA. And obviously the scoop or ducting is too big to fit in one print from the printer. So it is split in two. That's why you see this dovetail joint here and here. And that's just to kind of snap it on together and give it some structure. Here's the fit of the scoop. Super impressed that everything fit nicely, especially given that this was the first attempt at it. And I've already tried this with the bumper. It mates right up. So super cool. Let me show you how this scoop fits around the bumper. Here's the back of the bumper just sitting on a table. And I wanted to show you how well the duct crowds that opening. It is like dead on. Now that I know the main part of the ducting fits onto the oil cooler and bumper, I then made some brackets to kind of hold it. So when I made this bracket, I didn't want to waste printer filament to do the whole scoop again or duct again, because that's just a waste. I already know it fits. So I only printed the front portion of it just to see if it fits. So this will slip on underneath here. Doing it with one hand kind of sucks. Okay, there he goes. Kind of hard to see, but that's where the ducting will be bolted to. This is the final version of the ducting. So unlike the other prints, This one was actually printed with carbon fiber nylon. Has super high resistance to heat and other good properties like resisting moisture and chemicals. About 4 to 5 times more expensive, but I think it's worth it for the final piece. Gonna get this onto the car and see how it looks. Here's the final part mounted on the car, and it fits beautiful. But yeah, this is way nicer than the crappy sheet metal ducting I did. I still do need to glue it in place. I don't plan to keep it together with just some dovetail joints, although it is strong. But I'm going to be putting some glue on there to make sure it sticks. That's it for this one. I'm super happy with the scanner and printer that I got. The scan quality is pretty dang good, and given that it's portable, I'll probably be able to just bring it around and scan things or scan friends' cars or whatnot. And the printer quality, it's my first 3D printer, and every time I search, this printer always comes up. Super happy with the quality, especially printing carbon fiber nylon. I think that's just going to be a game changer for some of the parts that I make. So until the next one.